Hi everyone, welcome back in solving second order differential equation. So today we're going to continue looking at the general solution of homogeneous equation. Okay, so we are particularly interested in second order, but in this example it's a third order example. So find the general solution of homogeneous, non-homogeneous. Okay, not homogeneous, non-homogeneous equation. Okay, why is it non-homogeneous? Because of this. So if you look at the standard form, you have a3x y third derivative minus a2x y second derivative. Sorry, plus here, and then plus a1x y prime plus a0 x y equals to gx. Okay, when gx equals to 0, we have homogeneous equation. But when gx is not equals to 0, in this case, this example is not equals to 0, so we have a non-homogeneous equation. Okay, so this is how we want to solve. So to find the general solution yx, your solution will be, first you have the complementary solution. This one you obtain when this equation here equals to 0 plus with the particular solution that you obtain for gx here. Okay, so instead if it's given that yp is this and yc is this, so your general solution is given as yc, which is this one, c1ex plus c2e2x plus c3e3x plus with my yp. Yp will be negative 11 over 12 minus 1 over 2x. So this is my general solution for non-homogeneous equation. Okay, now we want to find yp. We know how to find yc. Okay, yc for second order, 3 cases: complex root, equal roots, and different roots. Okay, but we want to find the particular solution. Okay, so a particular solution yp, focusing on yp, for non-homogeneous linear differential equation, such as this one. This is non-homogeneous differential equation, your gx here. Okay, take note, my gx is not equals to 0, can be obtained using a method known by undetermined coefficient. Okay, undetermined coefficient. So this is what we want to look at. What are they? Okay, the few cases that we can consider. The function gx can be constant, polynomial, exponential, sine, cosine, infinite sum, or product of this function. Okay, some example of gx that we can consider are, this is constant here. Okay, gx equals to 10. Or gx is my polynomial for order 2. Or gx is an exponent function. Okay, we have exponential function. Or we have a sine function here, another polynomial, plus exponential, and then we can also have a combination, a sum of cos and sine, and we can have a polynomial, exponential, and a trigonometric function. So all this gx can be used. Okay, it's acceptable to solve using undetermined coefficient. This is what I mean, that all these coefficients are allowed to find. There are some coefficients where the method of undetermined coefficient is not applicable, such as for this type of function. If you're given ln x, you cannot You cannot. Your gx is ln x. So you cannot use this approach. Or your gx equals to 1 over x. Or gx equals to tangent x. And gx equals to arc sine x. Okay, so you cannot use undetermined coefficient when you have gx in this form. Other than that, you can use it. Okay, so let's solve. So how do you solve a non-homogeneous differential equation using undetermined coefficient? Okay, so first thing example we're going to consider is when gx is constant. So in this case, we have gx equals to 54. Okay, so we know that this is non-homogeneous. So to find the solution, we have yc, the complementary, plus the particular solution. Now yc is easy because yc you obtain by finding the characteristic equation for a homogeneous equation. So such as this is 0. Now I have m squared minus 9 equals to 0. So m squared equals to 9. M will be plus minus 3. Okay, so I have different roots. So for different roots, my my complementary solution is given as, okay, so I have yc is given as c1 exponent 3x plus c2 exponent negative 3x. Okay, this is my yc, where yc is obtained when the solution is homogeneous, like how you find a homogeneous differential equation. Okay, now by having that, okay, we have obtained yc. Now we want to find yp. Okay, yp is the one we need to find. So because gx is constant, we can let yp equals to a. Okay, if it's a constant, we let yp equals to a. And now what you find here, you find yp prime, which is 0. And then the second derivative, yp double prime, which is also 0. And then plugging into this equation here, what you have. So I have 0 minus 9. My y is my yp equals to 54. Minus 9, yp is a, equals to 54. So therefore, my a equals to negative 54 divided by 9, which is negative 6. Okay, so yp equals to negative 6. So then, we have yp equals to negative 6, and we already obtained yc, which is c1 exponent 3x plus c2 exponent negative 3x. Therefore, my general solution is given by yc plus yp, such that c1e 3x plus c2e negative 3x minus 6. Okay, so this is how you find a general solution if gx is a constant. So if gx is constant, you just let gx equals to a, or any constant. Okay, the next part is if gx is a polynomial. Okay, such that we look at polynomial power 1. Okay, so we have y double prime plus y prime minus 2y equals to x. So my general solution will be yc plus yp. Okay, first we want to find yc. Okay, yc is when this is equals to 0. So I have y double prime plus y prime minus 2y equals to 0. I have m squared plus m minus 2 equals to 0, and then factoring out, I have m minus 1, m plus 2. Okay, equals to 0, therefore I have two different roots, m equals to 1 and m equals to minus 2. So my yc x is given by c1 exponent x plus c2 exponent negative 2x. Okay, so that's how you find yc. Now to find yp. Okay, now we want to find yp here. Okay, so if you have a polynomial with degree 1, I will let yp equals to ax plus b. Okay, so because it's degree 1, doesn't matter. If it's degree 2, we have a different yp choice here. But because it's degree 1, we write it as ax plus b. Now you differentiate once and differentiate twice. So differentiating once will give you a, differentiating twice will give you 0. Now put this equation into this form. I have y double, so we're going to change this as yp double prime plus yp prime minus 2yp equals to x. So this is 0, y prime is a, minus 2, yp is ax plus b equals to x. Okay, simplifying, I have a minus 2 ax squared minus 2b. No, it's not x squared, it's just x. Okay, so 2 minus 2b equals to x. Okay, so we just want to compare. Okay, we want to compare this equation here. Okay, by comparison, what do we get? Okay, so we have a minus 2, let me just write it again. A minus 2ax, a minus 2, minus 2b, minus 2b equals to x. Okay, so we have a minus 2b equals to 0, and then minus 2a equals to 1. So a equals to negative half. Okay, substituting a to negative half inside here, we will have negative half minus 2b equals to 0, negative 2b equals to half, b equals to negative 1 over 4. Okay, so having obtained a and b here, okay, so I hope I didn't make any mistake here, but now we do here, we said yp equals to ax plus b, right? So a is negative half x minus b is negative 1 over 4. Okay, by having this, now I can write my general solution, which is given as yc plus the complementary plus the particular. So yc I have obtained earlier on, such that this one, c1ex plus c2e negative 2x, c1ex plus c2e negative 2x plus yp negative half x minus 1 over 4. Okay, so this is my solution. Okay, this is my solution for that polynomial given here. Okay, continuing, how if you have a yp or gx as x squared? Okay, your gx is x squared, which is a polynomial of order 2, of degree 2. Okay, polynomial of degree 2. So we have seen this one. This is last time we saw. This is where you get your characteristic equation. So the y c here, because we have looked into our previous video, which is y double prime plus y prime minus 2y equals to 0, you have obtained your complementary solution as c1ex plus c2e2x. Okay, so we have c1ex plus c2e negative 2x. Okay, that's my yc. Now, how do you find yp here? Okay, if it's x, my yp will be ax plus b, but this is x squared. So my yp has in the form of ax squared plus bx plus c. Okay, so this is my yp here. So now I need to differentiate twice and I need to differentiate once. Okay, differentiating once gives me 2ax plus b. Now differentiating twice gives me 2a. Okay, so once I have that now, I can write this equation here. Yp double prime plus yp prime minus 2yp equals to x squared, such that yp double prime is 2a plus yp prime is my 2ax plus b minus 2, and my yp is ax squared plus bx plus c. Okay, so now equals to x squared. So I have to equate the equation with the x variable aside and one variable or a constant aside. So if I'm simplifying this, I have 2a, just a constant, plus b. Okay, 2a plus b minus 2c. Okay, there is no constant. There's no constant here, right? So 0. So I equals to 0. This is my first equation. The second equation with the variable x. Okay, so I have 2ax minus 2bx. Okay, so that's it. So you have 0 here. So you can ignore the x actually. So just remove this x and remove it. Okay. My eraser is not working. Okay. So you don't have to actually write the x. So I'm just going to tell you, you take the coefficient with x here, 2a minus 2b equals to 0 because there's no x to the power 1 here. Now the next one, so I've already taken this one, and now I have negative 2ax squared, equate with this x squared, so which is 1. Okay, this is my second equation earlier on. Now this one, a is, we can find it, negative 1 over 2. Okay, so since we have a equals to negative half, I need to find the other coefficient. So if I put a equals to negative half into equation 2, okay, so I have 2a minus 2b equals to 0. A is negative half minus 2b equals to 0. Negative 4 equals to 2b. So b equals to, sorry, I can cancel this thing. Sorry, I made a mistake here. So it's not 4. Okay, cancels out here. So I have negative 1. So b equals to negative half. Okay. Now upon obtaining b equals to half, now what is my first equation here? 2a plus b minus 2c equals to 0. 2a plus b minus 2c equals to 0. 2a plus b minus 2c equals to 0. So we know a equals to negative half. So we obtain a equals to negative half earlier on. Okay, here. Now b is also negative half. So I'm sure we can find c easily. Okay, so we have 2 negative half plus negative half equals to 2c. So negative, bring it over here, you have a positive sign. Okay, so I have negative 1 minus a half equals to 2c. Okay, so I have negative 3 over 2 here equals to 2c. Therefore, c equals to negative 3 over 4. Okay, so we have obtained the coefficient A, B, C. So what is my YP? So my YP that you have in this form, ax squared plus bx plus c. Now a is negative half, b is also negative half, and c is negative 3 over 4. So this is my YP. Now YC that we already found earlier on gives us C1EX plus C2E negative 2x. Okay, therefore my general solution Yx equals to Yc plus Yp. Okay, C1EX plus C2E negative 2x minus half x squared minus half x minus 3 over 4. There you go. This is the general solution for homogeneous equation with constant coefficient. Okay, so I hope it's clear. Now I want you to try this exercise. So this is your homework. Remember, every time when there's a homework, you need to work it out and submit your solution at My Guru. Okay, so I'm just going to discuss this. So this is my YC. So find the characteristic equation and the complementary solution for this. Now this is my particular solution. So your particular solution will be in the form of AX plus B. Okay, what about this one? Okay, the particular solution here. Okay, so it will be in AX squared plus BX plus C. Okay, this is also AX plus B and this is X squared. Okay, there are some cases where your A and B can be simplified. So I want you to work it out. If you try to solve the coefficient, like for instance in this case, if you happen to not get the solution, that means you have picked the wrong YP. Okay, so you have to do it again. Okay, since we have time, let's look at polynomial with exponent term. Okay, your gx is in this form. Okay, so I want to just look at quickly because we have time here. So this general solution, if you have an exponent term here. Okay, so first you find YC. This is where you find when y double prime minus 4y prime plus 3y equals to 0. So you can factor, you want to find yc. So minus 4m plus 3 equals to 0. I can factor this out as y minus 1, y minus 3. I have two different roots such as m1 equals to 1 and m2 equals to 3. So my complementary solution is given as exponent x, c1 exponent x plus c2 exponent 3x. Okay, this is my yc. Now to find yp here, we must to find yp, we want to decide the choice of yp, the form that we want to take. Okay, yp. Now exponent here, to take an exponent here, because my gx is e to the power 10 times e to the power negative 2x, so the yp has in this form a e to the power of negative 2x. Okay, you follow this part here, and the constant you just write a. Okay, so similarly now you differentiate once, will give you negative 2ae negative 2x. Differentiate second time, I have 4ae negative 2x. Okay, now putting that into this derivative equation, yp double prime minus 4yp prime plus 3yp equals to 10e negative 2x. Okay, so put back all the equation here. 4e negative 2x minus 4yp prime is negative 2ae negative 2x plus 3a, yp is a, e negative 2x equals to 10e negative 2x. Okay, so to do this, I'm just gonna move on. So let me simplify first since I can. So I have 4a, okay, 4ae to x plus 8ae to x. So 4 plus 8, 12. Okay, 12 plus 3, 15a. So I have 15ae negative 2x equals to 10e negative 2x. Okay, let's write it in a proper form. So I have 15a e to the negative 2x equals to 10 e to the power of negative 2x. Okay, so equating the term here, okay, this is very easy, right? So 15a equals to 10. 15a equals to 10, therefore a equals to 10 over 15. Or simplifying, I have 2/3. Okay, then with this choice of here, we have my yp, which is 2 over 3 exponent negative 2x. Okay, therefore my general solution. Okay, don't forget your final answer. Okay, if you look at the solution is solve. When you say solve, we want to find the general solution. So general solution yx is given by yc plus yp, and yc we have obtained earlier on this one. c1ex plus c2e3x. 3 or 2, 3x. Okay, plus yp. Yp is this thing that you have obtained. So this is your general solution if you have an exponent term. Okay, now things can go further. So if gx is sine, how do you solve it? If gx is product sum of two term. How do you do it? We'll look into the next video. Okay, that's all for today.